one perspective question, and it is a power plant or the plant in Poolbeg, the incinerator, and it's looking for us to draw the perspective view of that incinerator. Okay, so all the information is in the question. We just now need to follow the instructions. Yeah, so there's 10,000. Yeah, so everything's in meters. So there's 10,000 millimeters in 10 meters, and then you divide that by 200. So the first thing that we would do is calculate all of that and then maybe write them onto the sheet. So I would have 10,000 divided by 200 gives us 50. So that means that there is going to be 50. That's going to be 25. That's going to be 100. 15. 50. 25. 15. And 70. Okay. So just if we're not sure again, 14,000 divided by 200 equals 70 millimeters. So I have all my millimeters in. Spectator point S is 20 meters from corner A, which is going to be 100 millimeters. Okay. The horizon line is 10 meters above the ground line, which is going to be 50 millimeters. Angles always stay the same, and then that is going to be 100 millimeters as well. So all my measurements are written on my sheet. The first thing I've done, and now I'm going to answer part A. So what I like to do is I like to draw it in the corner. Again, if you see other videos or other teachers or whatever, they might do it a little bit different to what I do it, but that's allowed also. And so we're going to draw the back of the incinerator here. I'm going to find the middle line. So it's 15, 15, and 50 is 75. I come across 15 and 25. No, sorry, is 80. That's 80 millimeters is the total width of it. 15, 15, and 50 is 80. I'll draw my center line coming down the middle. I have 70 millimeters. And 100 millimeters. Now again, remember just on the day of the exam, you'll be using A2 paper. This is A3, so it's it's twice the size, and it's going to fit. No matter what question you get, it's going to fit. So. So the angle then of inclination is 80 millimeters. Okay, so opposite angles. So I'm going to start this way. 80 millimeters will be that way there. Again, opposite angles, 80 millimeters. Come on guys, let's get a bit of work done. And then the angle of inclination from this front surface is 30 degrees. So it's 30 plus 90, which ends up being 120. So it's 120 to the horizontal or 60 to the vertical. So that there. Yeah. Okay, so again, just setting up the plan view here. We'll step out 100 millimeters. That will be my spectator point, labeled as S. Okay, so that's the easy part done. Now what we need to do is we're going to join the furthest point on the left. Furthest point on the left to the spectator's eye or camera phone or whatever you want to call it. Furthest point on the right to the eye of the spectator. Again to the lens of the camera or whatever it is. We then take that angle. We bisect that angle. And where the two lines cross, gives us our central line of vision. So I'm going to label that as CLV. And then the screen of your phone or the digital screen of the camera lens, whatever it might be, is always going to be 90 degrees to the direction it's pointing. So we'll slide this along until we get to corner A. That pink line is our picture plane, so I'll label that as PP. Now there's too much talk going on, let's cut it out, let's get working. And again, the vanishing points are always parallel to the surfaces that we're engaging with. So there's the angle of the edge of that surface or the object or the building. I bring that over to the eye of the spectator. I join that in and that's going to find me VPL, vanishing point on the left. That line is parallel with that surface, which is parallel to that surface. A horizontal line from the eye of the spectator is going to find me vanishing point on the right. That line is parallel with that surface, which is parallel with that one, which is parallel to that one. Okay, so they're all parallel to each other. Now, at that stage, I have all my information in the plan view found that I need. So what I'm going to do now is I'm going to untape the sheet. Okay, give it a little spinneroonie and retape it again in line with my T-square. So making sure that my T-square lines up with the picture plane, hold it in position, retape it up. And now we're going to draw our plan view. So The object is a total of 75 millimeters in height. If we look at our question here, the object is 75 millimeters in height, and then it says the horizon line is 10 meters above the ground line. Once I apply my scale to that, that means that my horizon line is 50 millimeters. So some of this object is going to be above the eye of the spectator, so I have to accommodate for that. So what I'm going to do is, this is going to be roughly where the top of the object is going to be. So therefore I'm going to step down from there the height of the building. So roughly the bottom of my set square there. So this is going to be the ground line. And I'm going to step up from the ground line 50 millimeters to the eye of the spectator, which is going to be there. So that's my horizon line. Now, again, because this is an A3 page, it looks like I've run out of paper. So all I'm going to do to accommodate that is stick an A3 page underneath it. Tape it down, and that will still get me out of a little bit of a spot. Okay. So again, that is my HL, which is horizon line, or the eye line of the spectator. And if I bring down my vanishing point on the right, bring down the vanishing point on the left, I'm now also going to bring down corner A, which is going to be my reference height line, or a measuring post if you wish. Okay, so that there is my reference height line. Okay, now any heights that are involved, I'm going to draw them on this. Now again, I'm not dealing with the sloping surface just yet. Okay, I will need it in a few moments, but not just yet. So 25 millimeters and then another 50 on top of that, which is 75 millimeters. So what I'm going to do then is I'm going to draw the first one at 25 millimeters, and I'm going to draw this in. So the surface going to the left goes like that. The surface going from the right at the base or on the ground looks like this. Now what I'm going to do is, just to help me visualize this and to place it, I'm going to label my points around here. So I have A, I'm going to work counterclockwise, so I'm going to go clockwise B, C and D. I'm going to go E, A, B, C, D, E, F, G and H. Okay, I have all my points labelled there, and that's going to help me construct this. Alright, now what I'm first going to do, and again I always want you to use the three-dimensional image that you have in front of you. Maybe colour your surfaces. So for example, this blue surface here, that surface there is going to be along here. Okay, this green surface here, this green surface here is going to be along there. So for the blue surface, we have the blue surface along here. I'm going to bring the height of 25 millimeters to VPR, VPL, VPR. Bring that height across. And we just need to figure out, if this is corner A, where does corner D happen? So up here, corner D hits the picture plane here on its way to the eye of the spectator. If we bring that down, we now have corner D. Okay. Now, at this stage, and just for handiness sake, I'm probably going to draw in the auxiliary vanishing point, but I might just leave it till the end, see if I can get anything else. Okay. So B here, eye of the spectator, where it hits the picture plane, we bring it straight down. So we'll bring that down there. Alright. So therefore I know that this is a heavy line. This is also a heavy line. Now what I'm going to do is I want to find E, because I know the height of E. E is 75 millimeters in the air. Okay. E is 75 millimeters in the air. So what I'm going to do is I'm going to travel from A to B and then back that way. So this vanishing point. So I'm going to go from A, 75 millimeters at A, back to B, then towards C and stop at E. So the height of 75 on the reference height line is here. I'm going to make that go towards VPL. Wherever it hits B, it stops. So I've traveled from here to here. Now I need to go in that direction. So that's the height of 75 at B. I'm going to make it go towards VPR. And then I need to bring E to the eye of the spectator. Where it hits the picture plane, I'll bring it straight down and that will find the location of E. So that there is the location of E. If I bring VPL through E, it will find me H also. So VPL through E, H can come to the eye line of the spectator. Wherever that line hits the picture plane, we bring it straight down. And that locates H. To find G, I already have H, so to find G, I'm going to travel along this line from H to G. That will bring me to my VPR. So, if I go from H towards VPR, G has to be somewhere along that. So therefore, I will do this. I can't see it. We just need to find a stopping point for H and G, and the slope from A towards B, so that we can find a stopping point for B as well, and then we can solve those stopping points for that then. So what I'm going to do now is I'm going to take the slope of surface B, which is at an angle of 20 degrees, okay, and I'm going to, because it's sloping in this direction, in the direction of A to B, it's associated with VPL. So what I'm going to do is take my protractor apply that angle of 20 degrees from the eye of the spectator. We're going to draw it in the eye of the spectator at an angle, and then we're going to come out at 90 degrees from the VPL. So we have a 90 degree angle here from the VPL, and that is going to give me the height. So this measurement here is the auxiliary vanishing point height. That height is then going to be applied here, and that will give us our auxiliary vanishing point. So this again, just to illustrate, that is the angle of 20 degrees. We take this height there's my height measurement, apply it to VPL. It's important that you apply it to the correct position. So this is auxiliary vanishing point left, because that's where the slope is going uphill. If that slope was going downhill, I'd apply it below the VPL. So now what I'm going to do is going to take surface A, point A, it's going to be sloping and vanishing towards auxiliary vanishing point on the left. D is also going to be doing the same, D towards C. And now we have our stopping point for B. Now, theoretically, if this is the bottom of B, that's the top of B, B would continue on to my VPR, and that would give me the back of it. And where it crosses this would give me point C. But because we can't see point C, we don't need it. Now, what I need to do is I need to find the height of H and G for where it intersects with surface B. So what I'm going to do is I've brought, as you can see here, GH1 across. If I find point 1 on the slope line of AB, then I can bring point 1 across to my vanishing point or, and that will give me the stopping point on that surface. So what I'm going to do now is I'm going to take point 1, bring it to the eye of the spectator. Wherever it hits the picture plane, bring it straight down to the line AB. There is point 1. I'm going to bring point 1 now to VPR. And that is where H stops, where G stops. That gives me that point there, and then the slope from the bottom of H to your auxiliary vanishing point is applied, and therefore that is what's drawn in heavy. If I refer back to my image, this is my green surface with the slope applied. This here was my blue surface. And then the red surface is going to be the slope. And again, we can have that highlighted in red. So the line DC, AB, HE are all going towards the auxiliary vanishing point. And that's how we apply the auxiliary vanishing point. Now for point C, okay, or for part B of the question. Part B says a vertical chimney is located at position C. It has a height of 20 meters, which is here. So if I was 20 meters tall and I was standing at A, I would be the true height. As I travel from B, or from A back to here and then back to there, I would, what would I look like when I'm standing there? So again, 20 meters for us is 100 millimeters in height. So what I'm going to do is I'm going to create a measuring line. So if we step out here 25 millimeters along the line CB, we get point C that we're asked to find. And what I want to do is I want to continue that on to get a measuring line here. I'll mark that along here along the picture plane and bring it back to VPR, because this line here is parallel to VPR, so therefore if I find 20 meters up against the picture plane and bring it back towards the vanishing point, I should have my location found. Now you can do this in numerous different ways. For example, I could bring it parallel to VPL, so I could use both of my set squares. I could come from here, I could bring it parallel from that to there, bring that down and use that as my measuring post. But I'm going to bring it to VP4. So if I continue this picture plane on, if we continue the line point C on this way, all I'm doing is creating a second measuring line like I have done here. So what I'll do as well is take my ground line, continue that on at here. I'm going to bring down my measuring point on my second reference height line. Bring down my second reference height line and identify this as reference height line number 2. On that I'm going to measure 100 millimeters. Now again, if the chimney was up against a sheet of glass, it would be exactly this length in this position, and if I'm up against the sheet of glass and I'm disappearing that way, I would stop at C. So therefore I'm going to do the exact same thing down here in plan. So the bottom of that, and as you can see, it hits corner B perfectly because I'm doing everything correctly. That is the ground line going back towards VPR. So this is the ground as it disappears backwards, hitting VPR. There's the height of 20 meters or 100 millimeters as it goes back towards VPR as it travels in that straight line. And all we need to do now is bring this point C to the eye of the spectator. Wherever it hits the picture plane, bring it straight down. And we now have our true location between the ground and what looks like 20 meters. C and C. And that is how we do part B of that question. Okay, so all I used there was a second reference height line. Now, part C, determine the angle of elevation when viewing the top of the chimney from point S. So all I'm looking for is the angle of elevation, which is essentially, if I had my, there's the eye of the spectator, there's point C, what angle is this at? What I'm going to do then is hinge that down and find my angle. Okay, so what I can do is I have more room out to here. So what I'm going to do is I'm going to draw a perpendicular line. I'll draw it in purple because we haven't used purple yet. Draw a purple line there. We'll measure that to be 100, which will be the same height as the pole. So basically, essentially, if you can imagine, the pole was sitting here. It's now bulldozed over. It's sitting down here. And the pole is now sitting here. It was 100 millimeters in height. If I join that back to the eye of the spectator, that will give us our angle of the elevation. Again, I'm just going to draw this line in purple. I'll just say and that angle happens to be 27 degrees. Okay, so that is that question completed.